highly cited and prolific researcher. She has co-authored over 80 peer-reviewed papers in top-tier venues such as this one. She received a Google Latin America Research Award. She was named among Chile's 100 leaders under 35. And she has done extensive service in senior roles, such as editorial board member, track chairs, program chair, and so on. And she's the co-founder of the local ACMW chapter for women in computer science in Chile. So, Barbara, we are very interested in your talk, and we're thankful for having you with us.
Having problems with technology, as usual. Okay. I think, I'm sorry, I'm going to change the setup so I can see my own slides here. I'm trying to get the same screen on both.
You're on extended screen right now?
Yeah, because otherwise I can't see them in front of me. Okay, thank you for your patience. So I'm from this beautiful country that is Chile. This is the Atacama Desert. I don't know if you heard of it. It's one of the driest deserts in the world. So this is the north of Chile. This is where you would want to start. And we have it's a very long country with a very diverse geography. This is the south of Chile, which is Patagonia. And so you go from a very dry place to a very rainy and cold place. And even you can go to the Antarctica if you're interested. So as it varies, we have all sorts of climates, and we have this amazing geography. And this geography comes with its issues. So our country is also quite disaster prone. We are very used to having different types of natural disasters, and it's usually to know that Chileans don't get scared easily with an earthquake unless buildings start to fall down. If that doesn't happen, we don't move from our desk. We're just like continue working. This is an emblematic photo. We usually don't have this amount of damage, but I will talk a little bit more about it. This was in 2010 when I was there, obviously. And this is the tsunami that came right after it. This is like remains from that tsunami that came 30 minutes after that earthquake. And if that were not enough, we also had a recent social uprising, which was October 2019. And this was just before COVID hit and the lockdown. So we were actually working remotely at the university since October. And we never got a chance to go back because then we started getting into lockdown and everything. And so we're quite used to disasters. And as kids, we learned that it's kind of, things are difficult if something can be easy, it's not going to be, things are going to be hard. That's kind of the Chilean way to think, okay? So just to give you a little bit of context of where I'm coming from, and well, also Chato, who is also Chilean here. And this is how that social uprising that I showed you before kind of culminated with one of the biggest marches in the history of Chile, which was over 1 million people. And what people were asking for was a new constitution. And this process has been going on for a few years. We still don't have a new constitution, and people are still working on it. But that said, and you saw my title, I wanted to clarify, this is not a talk about diversity in the traditional sense of diversity, equity, and inclusion, which is very important, and I do work towards bringing more women into computer science, and I do think diversity in that sense is extremely important for science and computer science. This is a talk about how our uniquely diverse circumstances, all of us, are a source of innovation, and it is important to embrace them. Diverse in the sense of geography, language, the amount of resources we have available at the time, and whatever our most pressing needs at the moment. All these things can guide research, and they're all unique to us. And also, I wanted to talk about how it can be worthwhile to spend time on niche research interest. Here, I forgot to take the time, so if you could tell me when I have talked for 20 minutes. Okay, thank you. I tend to talk a lot, so I just want to make sure. How it's worthwhile to spend time on niche research interest. So recently I was co-chair for SIGAYAR, and we had this talk, like, do we want to publish work that is very niche? And I think yes, because if it's relevant to a region, it could be probably relevant to others. And this is something that I think it's worthwhile looking into. Because of our particular circumstances, we might be interested in something that does not interest the mainstream. And I'm going to talk a little bit more about that. And also about working on problems that are apparently solved, that have a really nice working solution, but it doesn't work for us. Maybe it's scientifically not so interesting to go into that. We might not be able to publish on it, but it's still worth looking into. I will talk about 3 research cases that my students, my colleagues, and I have worked on throughout the years. One is on identifying misinformation in social media. The other one is on earthquake detection, also based on social media, and hate speech detection. 2 of these problems are still very important today. The first one, identifying an emergent event, like an emergent global issue from an extreme local event. This is a first look into misinformation and how we started working on that. As I was telling you, we are a very seismic country. This is a building that collapsed in half during an earthquake in 2010, which was an 8.8 magnitude earthquake. This is the 6th largest recorded earthquake in history. And I was lucky enough to be there, to live it. And things that happen during that earthquake, in general, constructions are very good. So if you're in Chile and there's an earthquake, you shouldn't be very scared, because everything tends to resist very well. This is a building that was not built that well, and it had some problems, but it became very emblematic of the situation. That's why I have the picture. And what happened is that 30 minutes after that earthquake, there was a tsunami. And the worst thing is that this tsunami was unannounced. So people know that when there is a strong earthquake and you're near the ocean, you should find higher ground. We know that in Chile, so people did that. But then we got contradiction information from our president, who was Michelle Bachelet, according to the information she had. And she said, don't worry, there's no tsunami, you can go back home. So people actually went back home, and then they were hit by the tsunami. And that's what caused the most casualties at that moment. So it was about 300 casualties from the tsunami and about 30 casualties from this massive earthquake. There were also lootings that happened that day, which were maybe, I don't know, a dozen in a city named Concepcion, which was the epicenter of this earthquake. And people ended up returning many of those things. So it was like they were scared. They wanted to get food and stuff and make sure they had it. And the thing that marked this situation is that we did not have communications for about 12 hours. This is internal government communication. There were none. So there was no satellite communication, I think there were no text messages, and there was no internet at the level of, like, national level. And this, even I think the satellite phones for emergency response were not charged at the time. So in 2010, Twitter had wide adoption in Chile because we had already had elections pretty early that year, or just before that. And so people had created the Twitter accounts to, like, do their comments on politics and everything. And this helps supplement the lack of communication because the international link that Twitter used was still up. So you could message your friends through Twitter and you could communicate what was going on through Twitter. And as the only news source, we found out at that moment during a crisis situation where you don't have other information, we saw that misinformation started running wild. And this is kind of just like the perfect storm because you have no other official news sources, you only have Twitter, and you have a crisis situation where people are really scared. People are afraid, they don't know if they're going to get like electricity, if their loved ones are okay, everything. So this started kind of becoming a very concerning situation, so it amplifies people's fears and it creates chaos and panic. We decided to do, at that time, I was working at Yahoo Labs in Latin America, and I was working with Carlos Castillo, who is a colleague who was in Yahoo Labs in Barcelona, and Marcelo Mendoza, who was also in Santiago with me. And we said, let's do a case study about how communication happened during this earthquake. And we were lucky to have that lab at that moment in Latin America, which was not a usual thing. And we had access to the Twitter Firehose data. And we were able to conduct a study. This is just an example of some conversation topics that were going on the first days. So you have that the first day, on February 27, people are talking about the tsunami. They want to know how many people have died. The second day, you're trying to find your loved ones. They're talking about missing people. They're talking about the epicenter, which was Concepcion. Third day, people are trying to find also, they're talking about aftershocks, also trying to find loved ones. There says Google because people were using a people finder tool that Google provided. And the fourth day, they were talking about a shift in the axis of the Earth. That was a conversation that was going around at the time. And we published this study as this paper called Twitter Under Crisis. Can we retrust what we retweet? And our main observation was that we looked at conversation topics, at rumors that were happening. So we did an automatic extraction of those rumors, but we manually classified them in the aftermath if they turned to be true or false. So we had several rumors that turned out to be false. After a lot of days had happened, you knew they were false, like 10 days later. Deaths of celebrities, a tsunami warning in another city named Valparaiso. This created a lot of chaos, like a person had a heart attack because they were so scared because of the tsunami. There were talks about generalized looting that did not happen. And volcanic activity as well. Like if an earthquake and a tsunami wasn't enough, there was also like rumors of a volcano erupting. And there were also true rumors. So there was actually a tsunami warning before the tsunami that would have been really helpful for everybody to know. There were people reporting that the ocean was pulling back and they were seeing that. So that could have informed also the authorities that this was happening. There was looting in a couple of supermarkets in a city in Concepcion, fire at a chemistry lab, as well as the Navy did acknowledge their failure to inform about the tsunami. So in general, we observed this high-level pattern. So we were doing this kind of data mining analysis to kind of discover what the information was telling us. And we found that if you had access to the entire Twitter network, you could see that things that appeared to be false or that turned out to be false, in general, people questioned them a lot. They were saying, okay, what's your source? Where did you hear that? Or people were denying it. I was there. I didn't see that. There was this general pattern, and almost nobody confirmed these things. If something turned out to be true, people were denying it a lot less. You couldn't find many people denying it. More people confirmed, and also less people questioned. And this is something you can still observe in any social media rumor that is going around. If you go and look at all the information, if you start doing broad searches, you can still observe these patterns. It's pretty easy to tell what is false and what is true. And we found that the people's perception, even in a scenario when you did not have external sources, was quite reliable in telling you what was going to end up being true and what was going to end up being false. So our the next idea was, okay, can we use machine learning to kind of automatize this? Because it was not a direct thing to see if something was going to be true or false. And what we did was label data of general trending topics and according to the perceived credibility. And our workers that were labeling that data could also use external sources to see if this was true or false. And we learned that task, and we were able to achieve pretty decent performance for detecting newsworthiness, as well as for detecting credibility, how credible the topic was for the network. We were not expecting to detect if something was true, because an event is still unfolding. We don't know if it's really true with very little information, but just to know if it was highly credible by most of the people. This is a work that was published at this conference in 2011, Information Credibility on Twitter. The key takeaway for me that I wanted to convey here about this work is that this insight into misinformation and why it was important was due to firsthand on-the-ground experience during this catastrophic event. If we had not been Chileans and interested in living in this country, we would have probably never had this insight so soon into misinformation, because this was the first work published in that area about noticing this problem that now is really huge and really important. And in an era of generative AI, it's becoming much, much worse. Introducing new ideas in this context is not easy, so it took champions and supporters. So we were kind of lucky in that sense that we had a research lab that could provide the data in South America, which is not something usual at the time, as I mentioned. And also the reviewers that saw this paper, they were able to anticipate that we would have impact, and they really defended it in the reviewing process. If you see a paper that you think is going to have high impact, and even if you think it has some small flaws, you should champion for it. The next case is about revisiting a well-studied problem from a different angle. And this is earthquake detection based on social media. I'm saying this is a well-studied problem because one of the first papers I'm aware of here is the one by Sakaki et al., which is called Earthquake Shakes Twitter Users, Real-Time Event Detection by Social Networks. And this won the Test of Time Award last year. So it also had a really high impact. And the premise here is that people are social sensors or citizen sensors. We all have varying degrees of sensitivity. So as sensors, we are pretty good. Some people will feel an earthquake even if it's very mild. Others will only feel it if it's really, really strong. And at any time of the day, there will be somebody awake that will feel it when other people are sleeping, okay? And the nice thing is that people report only on the events that can be felt on the surface. And this is not what happens with the physical seismographs that will report any event, even if it wasn't felt by others. And this was the initial work, and other agencies adopted it. So for example, the USGS, the US Geological Survey, yeah, they use a similar system, and they were actually very helpful in our work as well, in which they also use Twitter users to detect earthquakes worldwide. There's this other system called ESA or ESA by Robinson et al. In New Zealand and Australia, which is similar, and a system called EARS in Italy by Avvenuti et al. So this is a well-studied area, and there are good working solutions. And what happened? So we are there in Chile, and we were approached by the National Seismology Center and also the Navy. That was this agency that failed to warn about the tsunami. And everybody's very, very concerned on how to improve emergency response. And they had heard about this work that detected earthquakes using Twitter, and they asked us if we could provide a similar system. And we thought, okay, I mean, it seems reasonable. There's already so much work on it. We could probably implement a state-of-the-art for them, and it wouldn't take us much time. It would probably not be a scientific innovation, but we will do it because it's going to be a useful thing for the country. I'd like to explain why it is important to have this kind of detection based on Twitter. Chile is a country that has a very dense network of seismographs, which are the physical sensors, and these are very expensive. So you would think, why a country that has so many sensors and so many resources invested in this wants to use Twitter? And it was because of the reason I was telling you before. It's because even if a truck drives by, it will activate those sensors. So they're basically sensing earthquakes all day, and they cannot tell if the earthquake was strongly felt on the surface. And this information is vital. If you want to design a good emergency response, you need to know the effects of the earthquake. And how do they do that? What they do is that they have people in different parts of the country that will call and inform the amount of damage. They will report on the intensity of the event. And this is not very reliable. Sometimes the person is like taking a shower, or they were sleeping and maybe they didn't feel it. And it can take days to gather information about the intensity. And when you have a very strong earthquake, you want to know about the intensity right away so you can send help. We have this example. So this is the Turkey-Syria earthquake early this year, which was a 7.8 magnitude earthquake. This is the size of the earthquake. And in intensity, it scored the top, which is 10, extreme. This is like total destruction. And on the other hand, we have the Chilean earthquake, which was an 8.8. This is 8.8 is hundreds of times larger than a 7.8, because this is an exponential scale. But it didn't cause much damage. It actually registered about very strong, which was like a 6 on the scale, as opposed to a 10, as the Turkey-Syria. And this will depend on how deep the hypocenter of the earthquake was, also on the kind of the terrain, and also on the type of movement of the different plaques. So if they're moving like this, it's one thing. If they're moving like this, it's a different thing. If we had had the same movement in Chile, we would have probably had the same amount of damage. And that's why intensity and understanding how it's felt on the surface is important. And okay, we said we're going to implement this based on existing methods, which are very good. And they were mostly based on temporal probabilistic models, and also another approach that is short-term average, long-term average, which is used a lot in seismology, but all based on Twitter message arrival rates. So that's kind of the signal you're tracking. But this has a drawback. The drawback is that you only need to track messages that are talking about earthquakes, because Twitter is talking about everything all the time. So you need to have very reliable messages on which to trigger your alarms. So that was the restriction. And I will show you an example. You can have, Twitter is super noisy. So this is an example that I took a few days ago. These are 2 tweets that are talking about earthquakes. So they are relevant messages, but they're talking about earthquakes that happened a long time ago. They're talking about, one is about the anniversary of the San Francisco earthquake in 1906. So it's relevant, but it's not real time. The same thing happens for the other example that is talking about an earthquake in Indonesia. It's relevant, but it's not real time. And we also have other cases. This is a popular drink, like alcoholic drink in Chile that is called a terremoto. And it's, obviously, we're like a very seismic country, so we have a drink named terremoto. And we also have drinks called aftershocks. And we have one named tsunami as well. So, and this is drank during national holidays. So during national holidays, you will have bursts of people talking about earthquake, but they're actually talking about drinking earthquakes. So this is actually a totally irrelevant message for detection of earthquakes. So we had certain restrictions. The Navy and the National Seismology Center approached us, but they say we have absolutely no resources to put into this because the government is not going to give us funding if we have all this sophisticated equipment. They're not going to give us funding to use Twitter. It's not like an official information source. So we had to do it like without funding. We did not have money to like label data or to have an administrator that would be in charge of retraining a model that, because systems, if you want really good filters about relevant and irrelevant messages, what others were using was classifiers. So the Japanese were training a classifier in Japanese that would tell you if an earthquake was real time or not. And based on that, they would do the detections. So we had to skip that part. We did not have resources for that. And we could not run like heavy models because we did not have resources for a dedicated server either. And we decided, okay, if we're doing this, then let's do like detection for any language, if we're going to do it like for cheap. And we came up with a solution that was a noise-tolerant statistic approach that is also based on message arrival rate, but that it takes even noisy terms. So you can add any term in English that you think is remotely related to an earthquake, like shaking, and terms that are usually not used in the system, so you don't have to think about it. You just put anything into the system. And you can do that for any language. And since the system is the algorithm is noise tolerant, it works pretty well detecting. And the nice thing is that since allows for noise, we can detect also very low magnitude, low intensity earthquakes, which were not detected before. Before you could only detect really big events when a lot of people talked about it and they referred very strongly to it. So we were able to do that innovation based on our requirements. And in addition, we were able to add a Mercalli estimation that could be generated within 20 minutes. And usually Mercalli estimation, since it's based on human agents, what happens is that it will take days for you to get a Mercalli estimation. And this turned out in 2 publications related to robust detection of earthquake detection and also nowcasting earthquake damages. And that was the system, Twicali. And the National Seismology Center had it for many years on one of their really big screens, and they were using it all the time. And anytime our system failed, which was only a handful of time in 7 years, we got a call from the Navy asking us to like put it up. And we did not have a sysadmin, so I had to call my student, and she would have to get working on it. And it worked for like almost 8 years, and it was pretty scalable and provided worldwide coverage. You can still find the sources if you want to use it, but it stopped working at the beginning of the year with like changes made to Twitter. We hope that now the Navy will realize this is something useful to them and they will invest the resources in getting it up and running again. The key takeaway that I'd like to convey from here is that good ideas come only from a very deep understanding of a problem. This innovation emerged from an urgent local need, also by having limited resources and having a unique local perspective. This wouldn't have happened under other conditions. And these are things that are all over for us. We all are under those kinds of conditions at different times. The third example is about expanding existing research because we had multilingual needs. And this is hate speech. At the time we started researching hate speech, most of the approaches, this is just a few years ago, were not multilingual. There's still a huge gap between things that are done for English and things that are done for other languages. So hate speech, as you probably know, is viewed as a human rights issue, and women are affected by it disproportionately, also Black people, people of color, and other minorities. So there have been calls to social media companies to detect and remove hate speech, and many companies claim that it's their top priority to do this. But we have seen that in the past year, for example, Twitter has increased a lot the amount of hate speech that is on its platform, so it's not clear it's the priority. Some are more worried, others are not. And should it be responsibility solely on the platform? I don't know, there are lots of questions in this area. Also, like, what's the definition exactly of hate speech? I don't know if computer scientists are the ones to come up with that definition or not. And we found that this is a very well-studied problem for English, and there was excellent performance reported in the literature for this problem. There wasn't much information for other languages. And we were inspired to looking at this because we wanted to replicate a study we had seen from Amnesty International in which they had looked at the hate speech that women in politics received online, and they had seen that it was something that was really hurting their political campaigns. And we had an election coming up in Chile, so we said, okay, let's do this for Chile. So we need a classifier in Spanish. Specifically, we need one for Chilean Spanish. Anybody who speaks a little bit of Spanish and has spoken to Chileans will know that our Spanish is like totally different. So you need that kind of special classifier we were looking for. And what we did, we said, okay, there are so many approaches working in English really well, or that claim to work in English really well. We will kind of follow the same description of their architectures that they're putting out there, and we would just do a very naive thing. For example, we'll use machine translation and apply these approaches and see what's the metric that we get in performance. Or we will use universal word embeddings instead of, English word embeddings and see how it goes. So our performance was like really poor trying to do this naive adaptation. So the reports from the state of the art were like 93% F1 for English. For Spanish, we got 50% F1. And we wanted to really know what was the source. Like, is Spanish more difficult? Do we actually cannot do model transfer? Do we need to train a classifier specifically for Spanish? Do we need to invest in resources for Spanish then? We wanted to get to the root of this problem, but we decided, okay, we're going to replicate the state of the art exactly how they did it. So this required taking a really deep dive into the code of the papers that had been published and understanding exactly what they did until we could reproduce their results in English. So we did that. We reproduced their results, but that surfaced a lot of experimental issues. So what we found was that the works were reporting really good performance, but they had serious problems of data leakage between training and testing. And they were using the entire data set, for example, for feature extraction or for word embedding generation. The other problem we found was that there was a huge data bias in the most popular data set that was being used at the time. And I will go into detail about this. The data leakage was for one of the papers, so they were using the complete data set in the training phase for word embedding generation. This was generating overfitting. Also, another work was doing they had a high imbalance between hate speech class and non-hate speech class. So the hate speech class was a lot smaller. So they said, okay, let's oversample this. But they did oversampling before the train and test split. So what happens is that since they had so few points of hate speech, they ended up replicating the same hate speech points on the training data and on the test data. So they just learned the hate speech points. They did not have different points. And when we went to look into the data set that everybody was using, this data set did not have user-level information. So we had to go back to Twitter to download the user IDs and try to see which users had generated the messages. And we found that 80% of the hate speech messages were generated by only one user, and 90% of the hate speech messages were generated overall by 3 users. So what happens when you train a classifier on that data, you're not teaching it to detect hate speech. You're teaching it to identify those users. Okay. Is it 5 minutes or? I have 10. Okay. Okay. Yeah. Okay. Okay, regrouping. Okay, so there was a strong bias in the hate speech, and we ended up publishing a paper about this, about the reproducibility of this work, and actually recalibrating the performance of the existing work for English. It was not 93% F1, it was actually 51% F1, which was almost the same performance we had for Spanish. So we were not doing so poorly in that sense. And this reminds us that it's very important to focus on the data. For me, it's natural because I come from the data mining area, but I think, like with many people from machine learning that I have worked with, looking at the data is not always something important. And I think it really is, and we always have to do it. And as models become more obscure, like with deep learning and large language models and everything, I think experimental validation becomes key. I mean, we can still validate a model to see if it works well, no matter if this is a black box to us on what it's doing. So the key takeaway of this part would be that multilingual and multicultural requirements led us to have to do a deep dive into the data and the experiments of prior work. This allowed us to better understand model performance. Hate speech in that sense is a multidimensional problem, and it requires a multidisciplinary approach. I'm a true believer that computer scientists are not going to solve this problem, and we should not try to. We should try some things, but not by ourselves, okay? I have talked about these 3 cases, trying to illustrate the need for tapping into our own diverse situations. And we all experience a unique combination of circumstances, and this is a useful tool for innovation. I mean, we were in Chile, and we did these really cool things, I think. But also, not only tapping into our own diverse circumstances, but also into promoting research hubs in different places. So to have research hubs in diverse regions. This is very important because we need to facilitate research in certain localities that in turn that research is going to help innovation globally. In the social outburst that we had in Chile, it was very important to have independent interdisciplinary research centers. I was involved in this. Our government put out at the beginning a report that was called the Big Data Report that they, I don't know where they got it, from some private company, I think. And it said that the social movement was not a grassroots movement, that it was created by agents infiltrated on social media from like communist countries promoting this. And we as researchers did not have any evidence on that. We had been collecting data about the social movement like extensively. So we analyzed it, and we kind of raised our voice and said, this is not true. So we got an invitation into like the La Moneda, which is the White House in Chile, to talk to the chief of staff. And we thought they were going to ask us, like, why isn't it true? Like, they would be really interested. And they said, like, can you write a new report that agrees with our report? And we were like, no, we can't, and that's not ethical. We should not do it. Well, at least it was a democracy. We could say that, so it was good. And then the next thing we were asked to do was like, can you give us your data or use your data to help us identify the people that are participating in protest? And I was like, no, we will also not do that. This is not ethical. So that's why I think it's good to have independent research centers that will allow you to say that. And I have those headlines because it's actually made the headlines in the news, how the governmentally paid researchers refuse to help the government put people in jail. And about independent, these are like my last slides, but about independent local research. They're there to make sure people's interests are addressed and represented fairly. This is why they're so important. Large language models perform well in most of the tasks that I have shown you. Like we're at this point where we say, okay, now we don't need ad hoc models. We will just have a general model that solves everything. But this puts us in a very high risk of relaying important tasks and receiving inaccurate results and answers without realizing it. So that's why it's so important to always evaluate and keep evaluating and become very good at experimental validation. Diversity is increasingly important in times of generative AI. That would be my last message and the end of my talk. We're getting a microphone, I think. Yeah? So if this kind of data about natural disasters has been used for other things, yes, there is research in other areas. Specifically for hurricanes, there's some really nice work about estimating damages of Hurricane Katrina. I think this was in Science or Nature. Goldberg, I think. So it has been done. There's also work, the area of crisis informatics addresses this on detecting basically any type of disaster, natural or human-made.
More questions?
Are you worried that the change in Twitter will make this less possible in the future? The current changes in Twitter?
I'm sorry, I didn't understand.
So Twitter is changing at the moment. A lot of people are leaving, a lot of things are, you mentioned the changes yourself, more hate speech. So do you think the current changes in Twitter will make the sort of things that you're trying to do harder?
Yes, of course. I mean, we had a system that had been working like almost a decade and now stopped working. I think it would, they have the claim that they will allow good applications that are for good to continue working, but this is not clear to us. And to the moment everybody was using this for research because it was so easy to access the data. So I think it will take a toll on this kind of research, and a lot of us that work on this area are concerned, and we will have to go other places to find social data. And it makes you think about how important it is not to have any regulations about who is like, what's happening with these platforms when they become part of our collective knowledge, you know?
There is a question over there.
Yeah, you said something along the lines of how computer scientists aren't the ones to be solving the problem of multilingual hate speech. Can you explain that a bit more, and who do you think is well equipped to help them solve this?
Oh, yeah. I think computer scientists are one part. I mean, we could do the machine learning models to do detection, but it's like there are multiple players there. So you have governments that have to decide what are you going to do with hate speech once you detect it, and you have ONGs that will have to say what they want to be done to defend the people that they are advocating for. as well. In that sense, and also the complexity, I mean, about misinformation, for example, and about hate speech, there's not even consensus on the definition of hate speech. And I don't think it's computer scientists who should define it. I have been lucky to work in my research centers with people that are from like communications and political sciences, and you can really see that they have so much more knowledge than us in this area, and that this can be super valuable for this really complex social problems.
There's another question there.
Thanks for the presentation. My question is related to the generative AI and this new era. Do you think that now that they can almost solve all tasks, we should focus more on developing data sets that are unbiased and can be used to train these models fairly?
I'm not sure if the focus is on creating data set to train models. I think because everything goes into these models, even like data doesn't need to be labeled. So I think we need good data for evaluation, and we need good data to evaluate from different perspectives, and we need for me it would be more evaluation of what the models are capable to do, what the biases are, and how they work for different cultures, different regions, and I think that's something that is going to be like quickly left behind, I'm afraid. That you will see, okay, this kind of gives good solutions, I tested it for a couple of cases, and then I'll use it, production, you know, and so I'm afraid of that.
Is there any further question? All right.
So now you've published how to spot the difference between misinformation and true information. Aren't you worried that bad actors will start using that information to make their misinformation appear more real?
Well, what we published, this was in 2011, and now there is like a complete whole new scenario of misinformation. We were looking at things that were not being artificially generated, like in a massive way. Now you just have farms of production, and now you will have these models that just write perfect misinformation. So it changes completely. I think that's the least of my worries at this moment.
All right.
Yeah.
So to give people time to get to the next session, so we're very thankful for your keynote and your perspective. Thank you very much.
Thank you.